In this question, there are three identical masses placed at the vertices of an equilateral triangle of side L. We need to find the center of mass of the three-particle system with respect to one of the mass. If these three are the masses placed at the vertices of the triangle, side of the triangle is L. A, B, C, A, B, A, C, B, C, all these are L. Just for identifying the particle 1, 2, 3. All these are masses MH. For finding the center of mass coordinate, we need to have a coordinate system. We're fixing the coordinate with mass 1 as the origin. So for the first particle, it's at the origin. Both x coordinate and y coordinate are 0. So mass 1 is m. X coordinate of particle 1 is 0. Y coordinate of particle 1 is 0. Mass 2 at C. Mass is m. X coordinate means its distance from the origin to that particular point along the x-axis. That will be L. So x coordinate is L. Y coordinate for a particle on the x-axis, y coordinate is 0. Now for the third mass at A, mass value is same. Its x coordinate is how much it is away from the x-axis. So if you draw a line from here straight, this distance is exactly half of L, L by 2. So x coordinate means distance of the particle from the x-axis. From the x-axis, this much distance, which is same as this distance. That is half of the length. For finding the y coordinate of particle 3, it's a distance from the x-axis. Y coordinate is a distance from the x-axis. So this will be the y coordinate for particle 3. We mark this as y3. This is x3. Opposite sides are same. It's also y3. This also will be x3. You can find either by using Pythagoras theorem or by using trigonometry. This angle is 60 degrees because it's an equilateral triangle. If you take sine 60, sine 60 will be opposite side, y3 by hypotenuse L. Sine 60 is root 3 by 2. So L will come to the left, L will be y3. If this is not fine, you can use Pythagoras theorem. Base square is an additional method, no need, compulsory if you understood the first one, plus altitude square. Base square plus altitude square will be equal to square of hypotenuse. equal to L square. So y3 square will be L square minus L square by 4. Subtracting with LCM, 4L square minus L square is 3L square by 4. That's y3 square. So y3 will be root 3, 4 root will be 2, L square will be L. So whatever way you're getting, y3 as what? Root 3 L by 2. The easiest one is the first method. 2 steps you get. Root 3L by 2. When you find the x coordinate of center of mass, m1 x1 plus m2 x2 plus m3 x3 by the total mass m1 plus m2 plus m3. m1 x1 is 0 because x coordinate is 0. m2 x2 x2 is m into L plus m3 x3 so will be m into L by 2 whole divided by 3m. When you solve, the m get cancelled. L plus L by 2. 3L by 2. So 3 in the denominator. So L by 2 is x coordinate. For finding the y coordinate of the center of mass, m1 y1 m2 y2 plus m3 y3 by m1 plus m2 plus m3. So m1 y1 0, m2 y2 also 0, plus m3 is m, y3 is root 3L by 2 whole divided by 3m. The m get cut. Root 3L by 2 into this again 3 in the denominator. So the L by 2, root 3 and 3 get cut. 1 root 3 will remain in the denominator. So the coordinate x center of mass comma y center of mass will be x center of mass is L by 2. Y center of mass is root 3L. That is y3. Y center of mass is L by 2.
Okay.